Hello, everyone. Today we're going to go over section 5.4 on measurement and units. So there are countless different qualities that can be measured in our world. However, most units of measurement eventually relate to a few simple kinds of measurement. So far, we've looked predominantly at measures involving length and measuring discrete objects by counting. In this lesson, we will expand our view to measures of time, liquid volume, and weight. Our divisions of time may seem strange and arbitrary. 60 seconds in a minute, 60 minutes in an hour, 24 hours in a day. But 24 and 60 are particularly nice numbers to work with when doing division. Think about the number of different ways that you can divide the 60 minutes in 1 hour. 1 hour is 60 minutes. 1/2 hour would be 60 minutes divided by 2, or 30 minutes. 1/3 of an hour would be 60 minutes divided by 3, or 20 minutes. 1/4 of an hour would be 60 minutes divided by 4, or 15 minutes. 1/5 of an hour would be 60 minutes divided by 5, or 12 minutes. And 1/6 of an hour would be 60 minutes divided by 6, or 10 minutes. 60 has so many numbers that it's divisible by, and so does 24. In the US customary system, measurements of liquid volume are the most complicated. Because many of these measurements have historically been used for cooking, units exist which approximate the volume of any handy cooking utensil. For instance, 1 tablespoon is 3 teaspoons. 1 cup is 16 tablespoons. 1 cup is also 8 ounces. 1 pint is 2 cups. 1 quart is 2 pints. And 1 gallon is 4 quarts. We may need to rewrite the measurement of 1 pint in ounces. This conversion is not given explicitly on our table, but we have enough information to figure it out. We know that 1 pint is 2 cups. We know that 1 cup is 8 ounces. So we can set up unit conversions multiple times, canceling away the things that we don't need, getting us to what we do need. So 1 pint can be written as 1 pint over 1. And then we can change to cups with cups on top and pints on the bottom. Pints would cancel away, leaving us cups. Then we can convert with cups on the bottom and ounces on the top, giving us the ounces we need and canceling cups away. So 1 divided by 1 times 2 divided by 1 times 8 divided by 1 gives us 16 ounces. With that, we see that 1 pint is the same as 16 ounces, leading to the phrase, "A pint's a pound the world around." So 1 pint is 1 pound, or 16 ounces. With that, we move on to weight, defining the pound as the weight of 1 pint of pure water. We can also define the ounce in weight as the weight of 1 ounce in volume of water. So some weight conversions that we'll use is that 1 pound is 16 ounces, and 1 ton is 2,000 pounds. In example 1, we want to find the volume in gallons of 1 ton of water. Let's do our old friend, the 4-step problem-solving process, and start with understanding the problem. We're asked to convert from a measure of weight to a measure of volume. Normally, this would be difficult and involve some physics. However, we luckily know that 1 pint of water equals 1 pound of water. We have 1 ton of water in the problem, and we need to find the volume in gallons. We know that 1 ton is 2,000 pounds, and that 1 gallon is 8 pints. Step 2, devise a plan. We can convert these units by applying our 3 conversion factors. So here are the 3 conversion factors we're using. 1 pint of water is 1 pound of water. 1 ton is 2,000 pounds. 1 gallon is 8 pints. Carrying out the plan, we start with 1 ton of water, which can be written as 1 ton of water over 1. We want to get rid of tons, so tons are on the bottom. We can convert to pounds with pounds on top, 2,000 pounds over 1 ton. Then we can get rid of pounds with pounds on the bottom and pints on top, because 1 pound of water is 1 pint of water. Pounds cancel, leaving us with pints. And finally, we can get rid of pints with pints on the bottom, converting to gallons with gallons on top. Pints cancel, leaving our units as gallons. Doing the math with a calculator, we start with a 1 on top and a 1 on the bottom. Remember, numbers on top are multiplied, numbers on bottom are divided. 1 divided by 1 times 2,000 divided by 1 times 1 divided by 1 times 1 divided by 8. And that gives us 250 gallons, since gallons were the units we ended up with in the end. So looking back at our result, 1 ton of water is 250 gallons. The metric system, also called the SI system or the International System of Units, is an alternate set of measurements to the US customary system, which we discussed in the last 2 lessons. The metric system emerged as a result of the French Revolution, as odd as that may seem. Because of its simplicity, it was quickly adopted as the standard of the scientific community and has become the system of choice for measurement in all but 3 countries in the world. Those 3 countries are Burma, Liberia, and the United States. So if you travel abroad outside of the United States, unless you're in Burma or Liberia, people aren't really going to have an idea of what you're talking about when you use things like pounds or pints or gallons. The basic unit of length in the metric system is the meter, which is similar in length to the yard. The yard in the US customary system is currently defined as 1 yard equals 0.9144 meters, and that is an exact conversion. It's not approximate. The key to working with metric units is the use of the SI prefixes to create larger or smaller units. Kilo is times 1,000. Centi is times 1/100th, and milli is times 1/1000th. So for example, there are 1,000 meters in 1 kilometer, and there are 100 centimeters in 1 meter. This makes unit conversions within the metric system just a matter of moving the decimal point. As examples, if we had 123 millimeters and we wanted to convert to meters, the meter conversion is 1 meter per 1,000 millimeters. Since we want to cancel millimeters, the 1,000 millimeters would be on the bottom of the conversion factor. Dividing by 1,000 is just a matter of moving the decimal point 1, 2, 3 spaces to the left, the same as the number of zeros in 1,000. Dividing is moving it to the left. Our next example would be 456 centimeters, and if we wanted to convert that to meters, our conversion factor is 1 meter per 100 centimeters. Dividing by 100 is just a matter of moving 1, 2 spaces to the left. 1, 2 spaces to the left gives us 4.56 meters. If division is moving the decimal point to the left, multiplication is moving the decimal point to the right. So if we have 4.89 kilometers, getting rid of kilometers and converting to meters would necessitate us having kilometers on the bottom and meters on the top. There are 1,000 meters in 1 kilometer. So we are multiplying by 1,000. That moves the decimal point 1, 2, 3 spaces to the right. 1, 2, 3 spaces to the right gives us 4,890 meters. The basic unit of volume in the metric system is the liter, which is defined as the amount of liquid which can fit into a box measuring 0.1 meters on each side. The liter is similar in size to the US customary system's quart. 1 quart is approximately 0.946 liters. And the gram is the basic unit of mass and is defined as the mass of 1 milliliter of water. The more commonly used measurement, though, is the kilogram, which is approximately the mass of a 2-pound weight. 1 pound is exactly 453.59237 grams. So remember, you can use a note card on all of your exams in this class. You're going to want your note card for this exam to have all of the conversion factors that we've been discussing throughout this section. In fact, throughout this entire unit. The same SI prefixes that we used for lengths are also used for mass and volume, so the conversions will work the same way. For example, if we had 0.135 liters and we wanted to convert to milliliters, there are 1,000 milliliters in 1 liter. Liters must go on the bottom to cancel away. Milliliters must go on the top since that's the units that we want. 0.135 times 1,000 moves the decimal point 3 spaces to the right. We get 135 milliliters. And 776 grams converted to kilograms. There's 1 kilogram per 1,000 grams. Grams goes on the bottom to cancel away. Kilograms goes on top since that's what we want. And dividing by 1,000 is the same as moving the decimal point 3 spaces to the left. So 1, 2, 3 spaces to the left gives us 0.776 kilograms. If moving the decimal point is confusing to you, that's fine. Just keep using your calculator the way we have been. That's perfectly fine. You don't have to do it moving the decimal point. It's just a shortcut. Finally, we can use the definitions presented in this lesson to convert between measurements in the metric system and in the US customary system. For example, if we wanted to convert 18 feet to meters, we would start by looking at what conversion factors we have. Our conversion factors involving meters that have both the SI units and the US customary units would be that there's 0.9144 meters in 1 yard. So yards is going to be our halfway point between feet and meters. So we'll start by converting 18 feet into yards. 1 yard per 3 feet. Feet has to be on the bottom because we're canceling feet away. Yards has to be on top because we want to convert to yards. 18 times 1 divided by 3 gives us 6 yards. Then from 6 yards, we can do our conversion into meters. 0.9144 meters per 1 yard. Yards on the bottom to cancel the yards away. Meters on the top because that's what we want. 6 times 0.9144 divided by 1 gives us 5.4864 meters. So 18 feet is approximately 5.49 meters. As we saw earlier, rates are measured using compound units. one type of measurement divided by another type of measurement. We spent a lot of time in that earlier lesson talking about rate of speed, which we measured in miles per hour. Of course, outside of the United States, rates of speed are usually measured in kilometers per hour. For scientific results, speeds are usually needed in meters per second. Since our unit conversion table does not have any compound rates listed, we will need to rely on our algebra skills to perform these calculations. For example, to rewrite 45 miles per hour in meters per second, we first think of the rate as a fraction. Miles per hour is the same as miles over hours, so 45 miles over 1 hour. We first need to multiply by a conversion factor that will replace the miles in the numerator with meters. So how do we get from miles to meters? Well, we need to take a few steps, and those steps are going to take us through feet and yards, since our conversion factor with meters has to do with yards. So, canceling miles away first, we can go into feet. 5,280 feet on top, 1 mile on the bottom. Miles cancels away, leaving us with feet. Then we convert feet to yards. Feet on the bottom will cancel feet away. Yards on top. 1 yard over 3 feet. Finally, we can go from yards to meters. Yards on the bottom, meters on top, 0.9144 meters per yard. This gives us 72,420.48 meters per hour. But we didn't want meters per hour. We wanted meters per second. So now we need to do conversions to get rid of hours and get us into seconds. So we'll start where we left off, 72,420.48 meters per 1 hour. To get rid of hours, we're going to need hours on the top. 1 hour is 60 minutes. So now we have meters per minute if we do 1 hour over 60 minutes. And then to get rid of minutes and replace it with seconds, we would need minutes on top, seconds on the bottom. You might be a little bit confused at this point. You might say, hey, professor, previously the thing we wanted to get rid of, we would have to put on the bottom, and the units we wanted would have to go on top. And to that I say, that was when we needed the thing on top to be the units we want. Here we're trying to change out hours to seconds. Hours starts off on the bottom, so we're trying to change the bottom. So the bottom is what we keep trying to get into what we want. So 1 minute over 60 seconds cancels away minutes, leaves us with seconds on the bottom. Now doing the math, 72,420.48 divided by 60, divided by 60 again. I was just skipping over dividing by 1 and multiplying by 1 because we know that doesn't change anything. But if you want, 72,420.48 divided by 1 times 1 divided by 60 times 1 divided by 60 gives us 20.12 meters over 1 second. So 45 miles per hour is approximately the same as 20.12 meters per second. Example 2. Karen needs to purchase some weed killer and is trying to find the cheapest option. Flibble brand is priced at $3.73 per liter, while Quarkle is priced at $14.99 per gallon. Assuming that they are equally effective, which brand should Karen purchase? So when we go to understand the problem, we see that we are comparing the unit price of 2 brands, Flibble and Quarkle. Flibble is given in dollars per liter. Quarkle is given in dollars per gallon. Let's devise a plan. Because the unit prices are given in different units, we will need to convert one or both of them before comparing. We have straightforward conversions from liters to quarts and from gallons to quarts, so that's probably our best option. We need to be careful because the units of liters and gallons are each in the denominator of the unit rate. So remember what we're trying to cancel away and what we're trying to end up with. So we're going to convert both into dollars per quarts because we have 1 quart is approximately 0.946 liters, and we have 1 gallon is 4 quarts. It'll be easiest to convert both of these to quarts rather than going from liters to gallons or gallons to liters. So starting with Flibble, $3.73 per 1 liter. We want to change the liters on the bottom to quarts on the bottom. So quart goes on the bottom, liter goes on top to cancel liters away, and we use our conversion of 0.946 liters per quart. Doing the math, 3.73 divided by 1 times 0.946 divided by 1 gives us approximately $3.5286 per quart. Now Quarkle. We have $14.99 over 1 gallon because it's $14.99 per gallon. We want to cancel gallons away and leave us with quarts on the bottom because we want dollars per quart. We set up our conversion factor then with gallons on top, quarts on the bottom. That's 1 gallon to 4 quarts. 14.99 divided by 1 times 1 divided by 4 gives us $3.7475 per quart. So looking back, we can see that Flibble at $3.73 per liter is the cheaper option because the per quart price was less than it was for Quarkle. That's it for section 5.4. Next time I see you, we're going to do section 5.5. Get some of the homework done in the meantime.